Hey, good morning, dear faculties. Welcome to the day 3 of FDP program in AI with image processing. So last 2 day sessions we was discuss about the introduction of AI with imaging. So what is that? And yesterday we will discuss the tools and the frameworks. What are the tools we have to use? That kind of things we will discuss. Today we can follow with that techniques and algorithms. What kind of techniques we have to follow with the image processing. And before entering that, we will just recall the image processing. What is image processing? Like that thing we have to recall. Then we can entering into the major concept of today's topic. Okay, so just like that we have to see. Good morning everyone. Welcome, welcome to the stream. Yeah. So topic is AI with image processing. So already we was see about the what was that AI, right? So now we can entering into the image processing. So what is exact image processing? Oh, you did not get feedback link. Yeah, so every day I think the attendance, yeah, yesterday attendance link we have facing some technical issue. Then only we can't post the attendance link in chat box. So coordinator was sent in a group. Can you check with your WhatsApp group? Or else today itself we will share the both this yesterday and today's attendance. Yesterday saw some technical issue, so we can't post the attendance in chat. Okay, don't worry. So today we will try to share that attendance link. Okay, today we will get. You will get. Yeah, thank you. So continue with that image processing with OpenCV. So every image processing concept they consider the computer vision technique. So that's why we have to know. Yeah, so agenda was what is that exactly we have to see. So artificial intelligence we know already. So wherever every places, these are all the important things we have to create one AI technology, right? So planning, robotics, machine learning, NLP, perception, knowledge, cognitive system, and neural network, everything it helps to make one AI technology. Same like that, the AI will helps to create the image processing concept also. So what is computer vision already we know. So it's analysis for digital images by a computer for such applications. So industrial, medical, military, intelligence gathering, security, science, document processing, everywhere the computer vision will be there. Because everywhere that kind of places the image will be used. So that's why. So in industrial, the part localization, inspection and robotics, without camera they can't work autonomously. So that is a hardware thing and physical things they have to work. So that's why. And medical field, disease classification, screening, planning, that MRI scan, CT scan, that everything will help with the camera. They have to analyze and scan to our human body. They understand, we have to understand our situation, I mean understand our disease. And military related means autonomous vehicle and tank recognition, everything is there. So today the nuclear weapons is there, right? Once we have to launch in our country, they are go and blast in our opponent country with the help of the tracking and what was that sensor and camera wise they have to go and blast that opponent country. So with the help of the open computer vision concept they have to do autonomously without human interaction. Okay. And intelligence gathering, face recognition and video analysis, security is also video analysis helps too. Science is a classification and measurement, document processing is a text recognition, diagram conversion. So everything is one of the key factors of each department. So next one, what is exactly? So the form of artificial intelligence that trains computer to receive information from the digital and real world images. So computer vision trains the machine to perform and automate the task that typically requires the human intelligence. Okay, these are all the important, I mean exact thing of computer vision. So why we have to use this? So computer vision becoming increasingly important in various industries, including safety, productivity, and accuracy also. In this field of artificial intelligence, they have to help great importance to the AI. Without computer vision, there is no future, because they have to create the physical robots. So now the humanoid robots also they have to try to create. So without the computer vision concept, they can't understand the real world objects. They can't see the real world objects. So that's why it's without computer vision there is no future in AI. And 2.5 lakh opportunities are still it's available in this computer vision field. The average salary is nearly 6 to 8 lakh per annum. These are all the basic needs. How human vision and machine vision is there? So human vision means, as usual we know, so with the help of our eyes we have to recognize, with the help of the brain we can recognize that image is a cat image. Same like us, the computer is having the sensing device of the help of camera. So computer is having the eye is a camera. The recognizing part, it is a system, our machine or our model. With the help of eye sensing device camera wise, they have to see the object, then they have to recognize with the help of the computer, and finally it's got the answer, it is a cat. So there's a difference between the human vision as well as machine vision. So then same like that, human vision system and computer vision system. So the eye is a sensing device, is responsible for capturing the image for the environment, and brain is interpreting the device responsible for understanding the image content. So one bowl is there, inside the bowl what are all the things is there, the orange, banana, lemons, peaches, the fruits are there. Same like us, the computer is also working, sensing device, the interpreting device is a computer. So difference between the human to machine. So important computer vision applications, that is self-driving vehicles, facial recognition, healthcare, OCR like optical character recognition, super resolution imaging, and augmented reality. So these are all the important applications. How the Python programming is having game development, web development, application development, everywhere they have to use, right? Same like us, computer vision also having some individual things. So healthcare, facial, augmented reality, super resolution, optical character, like this. So trends in last year of 2024. What are the trends in 2024 in computer vision? So generative AI. So it is becoming a significant trend in computer vision because it allows the computer to create the realistic image and videos on their own. Instead of the relying slowly on the existing data, generative AI can invent the new visual content by learning the patterns from the data it's given. By using the generative AI, researchers and developers can make better models, create new visuals, and push the boundaries of what's possible in computer vision. OpenAI's groundbreaking tools of ChatGPT, DALL-E, and represent a leap forward in artificial intelligence. Because of these kind of things, they have to generate the new things. The ChatGPT and Perplexity, this kind of AIs, they have to create the new data. So whatever we ask, they have to create the new data. And DALL-E is generate the new image. So same like as DALL-E, like stable diffusion, DALL-E, stable diffusion, and Midjourney. These three models are familiar and important models for generating the image. Okay, and one more thing, so generative AI, I have to show them an example. I don't know I already show or not. So you go with your browser, you can search like this. So this person does not exist. Like this way you have to search. You can get one website. So the entire website is contains the multiple images, multiple people images. But what is that important thing is there means that every person is not exist in a real world. That is the important thing. The every images created by the generative AI concept, like the AI model only, they have to generate the images. So every time you have to refresh the page, you can get the random people. Now you can see. So you can understand. So it is a computer generator. So every time you can refresh the page, you can get the image like this. So it's an example, best example for generative AI, generate the image. So randomly the people's image will be there. So every time you can run, you can see that. So once you, just an example only I said. So if you have any free time is there, you can check with this. Okay, so now we can go and continue with this. So computer vision trends in 2024. So edge computing. So the edge computing is simplifies the way visually the data is processed and analyzed. Unlike traditional methods where the data is sent to the centralized server for processing, and edge computing brings this processing closer to where the data is generated, right at the edge of the network, such as on devices like smartphone, cameras and sensors. Everywhere they have to use. Like last session you was discussed how to read, write, color conversion. Same like some techniques also there, edge detection, morphological detection, smoothing image. So this kind of classical techniques also there. So the every advanced techniques will comes from the particular classical techniques like the morphological, edge detection, smoothing, blurring. So everything is there. The edge computing is computer vision enables the applications like smart cameras, autonomous vehicles and IoT device to make quick. So intelligent decision without always needing a stable internet connection and relying on cloud infrastructure. So merged reality. So the reality becomes like the 3D image creation, and we have to convert our own image into the different format like animated, drawing, pencil drawing, like that way. That was the best example. So the merged reality as a computer vision trend is represents a fusion of physical and virtual world through the advanced visual processing techniques. In simpler terms, it's about blending the real world environments with digital elements in a seamless manner. This trend leverages computer vision techniques to detect and understand the real world surrounding accurately. It allows the virtual objects to interact with them convincingly. For an example, it's augmented reality, its applications. Merged reality enables virtual objects to align with the real world surfaces and respond realistically to change the environment. So everyone we feel this, the AR, VR theater, a 2D or 8D theater, like that way we have to visit in our life in an amusement park, everything will be there, right? So they feel like we are in real environment. So just that was a projection only, but they have to given feeling like we are in the particular imaginary world. So that's the merged reality. So like this. So AR VR game only now it's there. So now they have most of the places they have to create the 3D or AR VR feeling like that way. They have to create. And 3D modeling, so already we know the 3D modeling is becoming a prominent trend in computer vision, and because it allows the computers to understand and interact with the three-dimensional object in more lifelike way. So like how we perceive the objects in the real world, and computer vision system equipped with the 3D modeling can analyze and manipulate the object from multiple angles. So we know the 3D is just still we will see everything is a 2D. Now this image or text, everything we will see in a 2D format, front or back, like that way we have to see. 3D means multiple angle we have to see. So every angle we have to see, they have to show like a realistic image. So a real object we have to see, like that way they have to give a feelings. That is a 3D image. So this technology is particularly valuable in the field like augmented reality and virtual reality and robotics and gaming, where the realistic representation of 3D object is essential for immersive user experiences and precious decision making. These are all the 3D modeling in 2024's computer vision trend also. So it's a 3D modeling, so we can see like this. So these are all the important applications. So face detection. So based on the face, they have to read a human face. They have to give a entire details about the particular person. that is the face detection, and age and gender detection. Based on the face features wise, what is the age, their age, and what kind of gender they are, like the way they have to detect. And face emotion detection, based on our emotion wise they have to understand. So we will try to see in still we have 2 days session, so we will try to see this kind of emotion also, this face emotion detection also. And cartoonify image, so that is a Ghibli art, so everyone you know, right? Recently they have to trend. So now trend in is nano banana, right? Before that the Ghibli art is a very familiar one. We have to give a prompt, the every image is create into the animation format, that is cartoonify image. So cartoonify image is a classical term, the Ghibli is an advanced term. That is the difference between the classical and advanced one. So next, the installation process already we know. So pip install. So first we need is Python software and OpenCV package. OpenCV Python we have to install like this. Okay, now we will come you later. So these are all the things is a image processing concept. So what is image processing? What are the applications is that? Still we will discuss. We must discuss about that. So now we can go with that. Our major concept. Techniques and algorithms in AI image processing. That is a very important thing. So today's topic also. So how we can start our journey in image processing? So already I think we will discuss, right? Starting with the foundational concepts. First we have to understanding the digital image pixels and the color space. So what all that we have to understand. Then classical techniques. So classical techniques are just now I said the filtering, edge reduction, feature extraction, image color conversion, and also image smoothing. This everything comes under the classical techniques. Every advanced technique comes from this kind of techniques. And a machine learning era, so the traditional ML approaches to image classification. And the deep learning revolution is a CNN, so it's a convolutional neural network, and it transfer the learning and modern architecture. How the deep learning will apply in image. So I already told this, right? In image we have to entering that, definitely we need a deep learning concept. Deep learning only handling the every data. So that's why. And advanced applications is object detection, segmentation, and generative models. I think already we was discussed the object detection, right? Today we can go with the generative model. So today our upcoming session we try to see the generative models. And understanding the digital images. So the image representation is that digital images are matrix of pixels and each containing the intensity values, and RGB images use these 3 channels. So I already know RGB means red, green, blue. That is the color. The every color comes from these 3 important things. This is the base, and which the grayscale images use a single channel, and resolution determines the number of pixels and affecting the both quality and the computational requirements. So the key color spaces are standard for displays and a camera. So now everyone can see in the RGB format, because every color we have to sense. So I think yesterday I have to show, right, the RGB format, the red, green, blue, right? And HSV, it is the negative frame like that. Yesterday also we have to see the example HSV format. The negative frame like that they have to show the separate color from the brightness. YCB CR is used in video compression. Once I think one simple thing is that is a video reversing concept. In that particular concept I will explain about the YCBR. And lab, so the perceptually uniform the color space. So we can maintain the color in the every images. So for an example, we have to recreate the one image, means we can maintain the same image, the painting, everything, the art generated, everything will be followed by this. So what kind of color we have to denote, we can maintain and we can follow the same color space. and classical image processing techniques. That was filtering and smoothing, edge detection, morphological detection. Okay, yeah. So filtering and smoothing is a Gaussian blur, reduces the noise while preserving the edges. So median filtering removes the salt and pepper noise, and bilateral filtering smooth the while maintaining the sharp boundaries. The noise means we will see that YouTube videos ranges, the pixel ranges or quality range we know, right? Starting from the 144 to still the 1080 is a normal video quality. The upgraded thing, some videos is having 2K resolution, 4K resolution, still it is a 8K resolution wise we have accessing to increase our quality of the video. So most of the video is maintaining the 720 to 1080, right? I think still our quality is also having is high qualities in 1080, I think, right? Why I can say it like that means the noise is represent to the particular blurring thing. We have to removing the unwanted pixel ranges, that is the noise reducing. So each blur is having the different things. The Gaussian blur to reducing the noise to preserving the edges, and median filter is helps to removing the salt and pepper, like the black and white pixel values that they have to remove. Bilateral filtering help to make the sharp boundaries. Now here one image is that the image edge we have to see clearly. That was the sharpness of the particular image. And edge detection is a Sobel and pre-width operators to detect the edges via gradients, and canny edge detection is provide the optimal edge maps through the multi-stage processing, including the non-maximum suppression. And morphological operation is the erosion and dilation of the modified object boundaries, opening the remove small objects and closing the fills gaps. These operations are fundamental for shape analysis. And feature extraction is shift and surf the detect, scale invariant key points, and hook the capture edge orientations for object detection. These features enables the robust image matching and recognition. So everything is having the individual techniques. So we try to see this each and everything they have to execute the process. And traditional machine learning approaches, the feature engineering pipeline. So how to extract the features and images and everything. The traditional ML requires the manual feature extraction and before classification. So the engineers craft the domain specific features such as color histogram and texture descriptors and shape properties. The feature extraction is shift, hog, LBP and color histogram. Feature selection is a dimensionality reduction via PCA format and feature importance. Classification is the algorithm names. This is support vector machine, random forest and k nearest neighbor algorithms. These kind of things we have to follow mostly in the image classification. So in right side they have to represent the common classifier of find optimal separating hyperplanes, that is support vector machines important note. And the random forest is ensembling the decision trees, and k nearest neighbors instance the based learnings. So each thing having a different thing, different to work. So once we are entering the one project concept, I will set which kind of algorithm we have to make and fit for that each classification. So next one CNN, so convolutional neural network, that is a CNN. So most of the image processing and image related projects we have to use the CNN, because CNN only contains the multiple layers. The images needed the to maximum highest level of layers we need to extracting the features. So that's why. And CNNs revolutionized image processing by learning the features automatically through the hierarchical layers of convolution, pooling and non-linear activations. So each layer having to do the different work. Now we can see the convolution layer to apply the learnable filter to extract the spatial features, and the early layer detect edges and textures. First is detect the edges and textures, and recognizing the complex patterns and objects. So the most important work of the convolution layer, it is detect the edge and texture, and it is recognizing the patterns of the particular image. Next, it's going with the pooling layer. The pooling layer is reducing the dimensional values of the extracted features. So retaining the important thing, and maximum pooling, select the strongest activation, and average pooling, compute the mean values. So the maximum pooling only to detect the exact object value. So for an example, the image is having the cat image. So based on the features wise, they have to generate the multiple values. So one animal they have to predicted by the CNN first layer. The maximum layer to select the exact answer for our output. Which one is the maximum value? Which neuron is contains the maximum value? That is our exact answer or exact output. The fully connected layers to combine the extracted features for final classification and connect every neuron to produce the probability distribution and over classes. So the fully connected layer to combine the every features, the every neurons. And landmark of CNN architecture. So landmark means the revolution of A we was C, right? Same like us here. Revolution of CNN models, like pre-trained models. AlexNet, first in 2012 they have to use. The AlexNet is containing the 8 layers, relevant activation function they have to use, and drop out the regularization and own the ImageNet by the significant margin and proving the deep learning potential. In VGGNet is a next layer, next model they have to use the 2014 year. 16 to 19 layers they have to contain, and using the small 3x3 filters. The image pixel they have to take it from the 3 to 3 row 3 column, like that way they have to splitting the filters, splitting the pixel values. They demonstrated that depth improves the performance, and these are all the VGGNet work. So they have contained the 16 to 19 layers, and the filters are assigning right to 3x3. It demonstrated with the depth improve performance. And the ResNet is a 152 layers with the skip connections and solving the vanishing gradient problem and enabling the training of every deep networks. That is the ResNet. Efficient net, it is a balanced scaling of the depth, width and resolution, and achieve the state of the art accuracy with fewer parameters. So now it's after 2019 period, they are entering into a YOLO model. So still the YOLO is yet version 10 is there. Version 11 is still processing. Already I told this. And advanced computer vision task. So already we see the object detection, right? So with the help of YOLO, they locate and classify the multiple objects within image. YOLO and faster the CNN detect objects in real time through the region proposal and classification. The semantic segmentation is assigning the class labels to every pixel. The UNet and deep lab architecture used to encoder and decoder the structures for precise pixel level prediction. So they have to find out the semantic segmentation. It is the image classification. We have to provide an image. In that particular image, what are the thing it's available? What is the thing? What kind of object present? They have to predict. That is the semantic segmentation. Instance segmentation is a distinguish the individual object of the same class. Mask CNN or RNN combines the object detection with pixel level segmentation mask. So here we have to take it as a personal. So some group of people is there. They have to predict the people, the person. Automatically they have to predict the person. But same person, what kind of gender they are. So how many male and how many female. Like that way they have to predict. That is the instant segmentation. This comes under the age and gender detection. Okay. These are all the advanced computer vision tasks. Already one I was done. Another two we try to see in upcoming sessions. And generative models and modern frontiers. Already I said generative is a most important thing is a GAN. GAN model is a generative is important model. They have to create the image, generate the image. So GANs is speech generator and a discriminator network against each other. The generator creates the synthetic image while the discriminator learns to distinguish real from fake and driving the continuous improvement. The most important thing, the GAN model have a two key models. One is a generator, another one is a discriminator. The generator model to create the image, the discriminator model to find out the which one is real, which one is fake. Like that way they have to classify the generated data. It's a GAN model. And diffusion model, it is a state of the art image generation through the iterative denoising model like DALI and stable diffusion create the photorealistic image from the text description. So based on our text prompting, they have to create the new model, new images. That is the diffusion models. And vision transformers are apply the attention mechanism from NLP to images. So the VAT process image the patches as sequences, achieving the excellent result without convolution. So NLP means same like a text wise, image wise, everything can applicable in this vision transformers. So text wise we have to provide, they have to convert the image. Image to image translation also we have to do. That is the thing is in vision transformers. These are all the important of and the frontier of the computer vision concept. So final takeaways, key takeaways are classical techniques remain relevant. Deep learning dominates the modern application. Choose the right tool for your task. First one, classical techniques already said is edge reduction, filtering and feature extraction. Provide and interpretable baselines and pre-processing steps. Deep learning dominates the modern application. Now we will say the stable diffusion, everything will comes under that. CNN transformer achieve the state of the art performance through the automatic feature learning. Choose the right tool for your task. Consider the data availability, computational resources and interpretability requirements when selecting the algorithms. These are all the key takeaways. Okay, so these are all our today's topic of techniques, tools and algorithms. So now we are go with that. Repeatedly we see deep learning will help. Deep learning will help. How it is help to classify the image. So we will see now. So we can start it from the what is exactly deep learning. We can forward by that. That is what most understanding. The deep learning concept is ability of a machine to imitate the intelligent human behavior. A machine learning already we know. So the application of AI that allows a system automatically learn and improve the experience. The deep learning is an application of machine learning that uses the complex algorithm and deep neural networks to train a model. This is our important thing. Okay. So the machine and deep learning both are subset of the AI. So without this we can't create the AI. So already I told this. And deep learning is made up of neural network with a different layer. And neural network attempts to the model the human brain's behavior by learning from the large data set. Can be used of the things like images, understand the speech and processing the language. Everything will comes under the deep learning concept. Why deep learning we have to use? Data growth, hardware advancement, Python and open source and the cloud and AI boom, everywhere the deep learning is important to understanding the particular concept. Why do we need? So processing the huge amount of data and perform the complex algorithm, achieve the burst performance with a large data set and extracting the feature. So these are all the important deep learning concept. So why this way, For this purpose only we have to use the deep learning. So already we know this is some subset of machine learning and artificial neural network to solve the complex problem with the help of the composed many layer of interconnected nodes, which allow them to learn increasingly sophisticated representation of data over time. Deep learning has been used to achieve the state of the art result in a wide range of fields, including the computer vision, NLP, speech recognition, and robotics. Robotics, everything will be comes under the deep learning concept. Framework, so TensorFlow, Keras, PyTorch. So last time we was doing a game in this particular framework. So most applications, cancer reduction, the deep learning. So how the Python and machine learning having individual applications. Same like us, deep learning also individual application, that is cancer reduction. The image base also we have to detect. Robotic navigation, so the automatic smart vacuum cleaner, they have to working selfly without human interaction, they have to work, so they need a process. Self-driving car, so distinguish the different types of object, people, road sign, and it drives without human intervention, so automatically they will drive. So translator also working like this, what kind of language we need, they have to convert. Music composition, so everything is the application of deep learning. Deep neural network can be used to produce the music by making the computer learn the pattern in a composition. So now we comes to the neurons. So neuron is the input variable 1, 2, 3. So already I told the every data to splitting into the multiple neurons where they have to split it. So now here the x1 is one of the neuron, x2 is one of the neuron, x3 is one of the neuron. The every neurons is going to the layers. So now they have to represent the neuron, but it is the layer count, major layer neuron. The individually they have to crossing into the every layer. Finally, the output will be based on our input dependent variable. It is independent, but our output is depending on this kind of neurons. So that's why they have to represent like this. So now the x1, x2, x3, x4, everything is a individual neurons. So every neuron passing to our every layers, they have to contain the one weight value. So the x1 is the weight value, they have to mention. X2 second neuron's weight value also consider. Third neuron's weight value. Still, how many neurons they have to split that? How that much weight values also they have to contain to go with the next layers. That helps to reducing the dimensionality. Finally, the activation function only to apply with the help of maximum pooling layer. They have to identify the exact answer. Finally, the output will be there. So the poster today like that x, y, z is the individual neurons. The x neurons contains the one weight value, y neurons contains the one weight value, z neurons contains the one weight value. So what is exactly neural network? The deep learning is based on the functioning of a human brain. Let us understand the biological neuron look like. So now it's a dendrite, cell nucleus, axon, and a synapse. So here we can understand to this. So here it is a input range, input layer. And the dendrite is input layer. The cell nucleus is a weight value. Axon is a what is that? Hidden layer. Synapse is the output layer. Again I repeat, the dendrite is the input layer. So in this place the neuron, the first every data will be inside the process. The cell nucleus is the additional weight value added to the every neurons. The axon is contains the hidden layer. So in this place these are all the hidden layers, every part. So the data has been processing in this place, then it came out to the output. So synapse is a output layer. So like this. So the input layer, the multiple hidden layers, the output layer. So in between these three layers, the data will be splitted and extracting the features. Finally, everything will be assigned to the one multiple classes. Based on the top three classes, the output will be there, only one. So what is that exact image we have? The exact name will be there. So like that way they have to predict. And neural networks, how it is work and what is that? A neuron is a basic unit that receive the input from other neurons or from the external data, processes the input and produces the output signal. The output of the one neuron can be connected to the input of another neuron, forming a network of interconnected neurons that can learn to recognize the patterns in data and make predictions or decisions based on the data. A typical artificial neural network consists of input layer, hidden layer, output layer, supported by the activation function and optimizers. So layers in neural network. So input layer, hidden layer, output layer. The inputs to represent getting the input data and represent the each neuron for the each data. The number of neurons in input layer depends on the dimensionality of input. The hidden layer can where the network learns the recognized complex pattern in the input data. So each neuron in a hidden layer receives the input from the neurons in the previous layer and produce the output that is feed into the next layer. So that this kind of things I will explain the before. So each layer is extracting the one feature. So that feature is going to the next layer. So what that understand on recognizing the patterns, that patterns is followed by the going to the next layer. That layer to processing that particular extracted features. The output layer to produce the final output of the network, which can be prediction, a classification, or same other type of output. What they are exactly expect? We are expecting the classification or regression, whatever. So now we can try to understand. So how do image processing recognition will be work. So before that we have some group of images. So some two dog image, two cat image. The artificial neural network it help we have to train. So we have to using this image for the training purpose. So there are ANN neural network to train with this image. Then we have to feed it to the new image. So it is a training image, this is the testing image. We are not feeding the same same data for the testing purpose. Same like us, we have to show the different image. But not as the cat and dog, everything is having the different breed. So right, starting from the lab breed or country dog breed and the Eskimo breed, husky. So individual breed is having. So randomly I have to try to create a training purpose first. Is a training purpose I have to create in our ANN model. Then I have to give a new images. The ANN model try to find out based on the features wise. So now is the testing image means based on the dog's features wise they have to comparing with the training image. Finally they get output. So it is a dog image and it is a cat image. Like that way they have to predict. So every training purpose we have to give a data into the multiple maximum data we have to huge amount of data we have to need to training, because every angle is important. Because user it is not we cannot expect user giving a same position. So we have to give a 360-degree way every images is needed. So that's why we say the prediction process, the training process to take too much time, too long. Okay, that is the image recognition. Like this way the image recognition will be happen. So now we can see. So it's a training data, I have to provide it to the ANN model. Here they have to identify the every edges. So eyes wise every edges and nose and ear place, the position, sitting and standing position. So every position is needed, right? First they have to recognize the sitting position image is one of the image, and standing position image I have to give it. Just an example, I provided the only two images. We have to manually to give a training process. Entering the training process we needed too much data. So every position, if top angle, wide angle, right angle, at every angle is needed to for our training process. So after this training I have to give a testing. So different images, sitting image, lying image and standing image, like that. randomly I have to give an image. So the model will predict it is identified by it's a dog. Based on the features wise, they identify it as a dog image. Like this way only the every image recognition will happen. And our object detection, everything will be happening like the same format, followed by the same format. So multiple layers, it is a single layer, that is multiple layer. So single layer is enough for the text prediction only. It is not a need to the multiple layers, because it is related to the numbers, so easily they have to classify. So we have to pass it to the image, means that is the only we need a multiple layers. Fourth layer will be do their own process, second layer will do their own process, third layer will do their own process. Not one single layer, they can't do the every process. Okay, so in every company is also same like that. So employee is there, team leader is there, and the manager is there, then the owner is there. So like that way they have to create. The owner, they can't do the every work, so they have to assigning the manager. The manager also they're not taking the every work, they have to split hiring the team lead. The team lead will leading the team of employees. So like this way have also the multiple layer will be followed by the first layer will be containing do their own one kind of works, second layer will do one kind of work, third layer will do one kind of work, like that. Then we can go with that what's happening in neural network. So already told it's a neuron, the weight input value, it's splitting into the neurons. The neurons contain the weight value, the weight assigning with the weight value, the every layers and every neurons passing to the hidden layers. The layers will processing the data, then it's go with the activation function. The activation function only to recognizing the exact output, finally the output will be there. So what is weight? The weight is represented in the strength of the connection between the neurons. In simplest way I have to try to explain you, so just wait. In right way try to explain you. Okay. Okay, just a minute. Okay, first I will told you how the image will be splitted to that. So now it's one image, right? So inside the image one person, I think one person will be there. Okay, so in this image, how they have first they have to entering into the layer process. So here the image is contains the grid format, right? So everything will be contains like this. So pixel values. Once you closer to your eyes, you can see your mobile that also having some pixel value, like some boxes is there. You can see some boxes. Everything is a pixel. This pixel is contains to the like this format. So it is a pixel. So inside the pixel having some values. So so randomly the values is that 2, 3, 5, 1, 6, 7, 8, 9 and 0. So like that way. This is the way every pixels contain the values. So like every pixel is the first one is the second one like this, third, fourth, fifth, sixth. Every edges is contains to the converting the pixel values like this, the layers. The image layers is like this. Yeah. So each box is having like this kind of values. Inside the pixel values is mentioned represent to this. So same like as behind some. So like this way every images will be created the multiple pixel pixel matrix where they have to splitted and they entering into the layers. Okay, so it is the first one. And the weight value, now we have to discuss the weight value, right? So the weight value is same like that I have to create here. So now value is that the weight is helps to, it's a borderline to prevent the values. The weight is created to the outline of the particular neuron. Here we can take this image, I mean take this values as a pixel. So 1 to 0, 1.1, 2, 3, 5, 6, 8, so 4 like this. So output line, the outline has to be created by the weight values. So just now we have to see the weight represents the strength of the connection between the neurons. So it is one of the neuron. In this neuron to create the outline, that is the weight value. So here the randomly the values is there. To prevent the reducing the exact pixel value, is the original pixel value. Here the weight values is helps to make that duplicate value we have to, or dummy value. So every layer they have to passing one layer into the another layer. Definitely we can get it the some waste we have to say any kind of work we have to do, we can get some kind of waste things, right? So we have to cooking means some kind of vegetable waste is there. We can make one product means some residuals will be there, waste residuals. So like that way here also will be there. That weight value is helps to avoid the exact data's weight waste values. So that's why we have to choose this. Okay, and weight is a scalar value that multiple the input of the neuron to produce its output. A bias is a scalar value that is added to the weighted sum of the inputs to shift the activation function of the neuron left or right. Together, the weight and the biases control the behavior of the neural network and are adjusted during the training to optimize its performance. So before entering the new layer, the weight value will added. After entering the layer, they can getting some reversed values, right? That is represent to the bias. Weight in input multiplied by the bias. That is a weight and bias. And activation function helps to are mathematical equations that determine the output of a neural network model like yes or no. It maps the resulting values in between 0 to 1 or -1 to +1. You have to select the activation function based on the problem. Some of the activation is sigmoid, ReLU, softmax. So each one having the different work. So we have a yes or no type, this or that. Like that way we have to get a prediction means we are using the sigmoid. The softmax is helps to multiple classes, multiple animals they have to our images contains means we need a softmax function. That is a multi-class classification. So different activation function is there based on our Based on our query wise, we have to choose the activation function. Okay, now, so this is the activation function, and weight and bias like this. So here the weight value will be contains in our exact neuron. Once entering this first layer, like first hidden layer, they contains the first bias value, 0.45. The second hidden layer contains the 0.50. So every layer the bias value will be added. So next is the forward propagation. Here it is entering to the deep concept. So now we know. So now we need to know. So what is that exactly? Okay. So it is process of passing the data through a neural network to produce an output. It is a normal way to execution. So here we have to pass it our input as a neuron. The neuron is convey into the hidden layer. The hidden layer to processing the data. Finally, it going to the output layer. It is a forward propagation, forward step. When we have to go with that backward propagation. The backward propagation means when our data will not predict properly, we have to do with that backward propagation. Yeah, last function, just now I said the last function, it is a mathematical function that measures the difference between the predicted output of a machine learning model and the actual output. So the backward propagation, just now I said, when we are not getting the proper output means we have to go the reverse process. So in here output will be came, again is going to the reverse process. The output to go in the output layer, the layers gathering the every data to the last hidden layer, then it's going to the next hidden layer and the first hidden layer, finally it's going to the input layer. Again it is do the front propagation. So every reverse process will be there means they can collect the every data. Okay, the output layers contains the one particular data is there, right? They are collecting the every residues and every waste data and everything, every bias values, everything they have to collect and move on to the next before hidden layer like this way. The weights and biases are adjusted based on the error between the predicted output and the actual output. It works by the propagating the error backward through the network, starting at the output layer and working backward to the input layer. Okay, so like this way they have process will be there. So it's a recap. So the forward propagation is the input and a weight followed by the bias to the hidden layers, then going to the activation function, finally its output. The backward propagation reverse things. So it's going entering into the output and going to the last function and to optimizer until new weight and bias. Again, we generating the new weight value and a new bias value of our exact data. Okay, so this is the way it has happened. So no need to know everything is today itself. Okay, we are getting some confusion. So just we have to stop with this place. So what is forward and backward propagation? Tomorrow we can continue with that. What are the activation function, last function is there? We can continue with that because it is fully theoretically we have to entering means it's getting bored. So that's why. So now we can go with that. What is that? Our hand gesture detection. So yesterday I have to show the example, right? So now we can go and see the explanation about that concept. Okay, so now I have to go the particular project. Okay, I will open this in ideally. First I will explain this end of the session, end of the, so after the explanation I will run this one. So already we will see about how to run it is executed. Again we will try. So first CV2, that is a computer vision, because it helps to analyzing the, because it's image or frame related, so that's why we need a computer vision. NumPy is handling the numerical values. MediaPipe, it's connected the every individual models to our class files, so the pipeline is needed. TensorFlow is a framework, it is helps to create values in deep learning concept. The TensorFlow also contains the models, so it helps to load our model. So models dot loading our model, and the Keras 3 version is important to executed the every features, the pipe, in my hand some kind of drawing will be there, right? That also we have to create. So here I have to using the pre-trained model. I am not used to manually train the model. I am using the pre-trained model. Okay, now before that I will show the model here. Here two kind of models will be there. Sorry, model file is there. Keras metadata, saved model, like two model I have to represent here. So now the MP hands, MediaPipe hands I have to create. MP solution dot hands. The hands is created to the number of hands. How many number of hands we have to provide? MP hands dot hands. The maximum number of hand is a 1. Only one hand only we have to show. 2 hand means we have to train. So the model only trained for the single hand detector. That's why I have to mention the 1. And minimum detection confidence is a 0.10. That is the range of my distance, range the distance between the camera to my hand. And MP draw means MP solution dot draw utils. Drawing utils means in my hand some layers, the edges will be there, right? The pointers, that is the drawing things. The model, so based on the pointers wise, the gesture will be deducted. So model is a K3 dot model of the load model. We have to create the folder like a MP hand gesture. And here I have to open the file. So in the folder everything will be there. So it's a for in this inside the folder we have to create the saved model. Every model will be there. Same like as gesture names also there. So what are the names? So the OK, peace, thumbs up, thumbs down, call me, stop, rock, live long, fist and smile. So it's around 10 I think, right? Yeah, 10 kind of classes we have to create. We have to detect gestures. So here we have to open the particular text file. So open the gesture name dot read. So R is in read the file. Class name f dot read to splitting the files like class names into the one by one. F dot close. Once we have to read the file, what are the class name we have to take and close the file. Then we have to print the class names one by one individually. Then we have to initialize the webcam. So real-time camera helps to detecting our edges, right? So caps equal to cb2 dot video capture 1. So I already represent 0 is an system default camera, 1 is an another device. And then the while is true. The when the true means when the condition is true, the loop has to be end. So the frame has to be read. So with the help of the cap, the frame will be read here, and XYZ, that is the multiple frames to assigning our values, the key values. So frame dot shape the reshaping the key values, and the frame is equal to cv2 dot flip. So every camera is reversely they have to showing the thing, right? So that's why the flip of the frame. And GB means color variation, that is RGB color. It is not a black and white frame, color frame we have to use. So frame at GB. So last session we have discussed the convert color BGR to gray we have to use. Here BGR to RGB. And the result is equal to hands dot process. Once the frame has to be detected, the hand also detected means it's going to the processing the hand. Then the class name we initiated one by one. So inside the empty string. And if the result dot multi-hand landmarks, the landmark will be stored, the landmark values are stored inside this list. Based on the values wise, the text will be there in our output. So for hands, landmarks and dot one by one. So a landmark X and landmarks Y input and output way they have to execute. And drawing the landmarks. So mp dot draw the landmarks in our hand frame, hand landmark and hand connections. Once I show the output, you have to understand better. So now we can see the thumbs up. Here the particular point has every edge just deducted the one point. So it is a thumbs up, thumbs point, second point, third point. Every pointers will be represented based on the folding my fingers and the hands. They have to detect the gesture. They are not recognizing our hand. The draw lines wise they have to recognize and identify the gesture. Okay. So that's why I have to try to say it here. And the class ID, class name will be initiated one by one and show the prediction on the frame. So the put the text and the frame and the class name wise they have to initiate. That means the class name we have to show in the frame. So the style of the font and the size of the font, everything will be have to denote. And cv2.im show means they have to execute at the frame, the output frame. The final thing, if cv2.wait key 1, so already I told you it's waiting some 1 minute. When we enter into the queue, automatically they have to exit to the frame. The cap.release means that they executed the capturing frame. They destroy all windows. Every windows apart from the display will be there in front of the display. The window will be there in front of the display. So first we have to load the libraries. Then we have to create the media pipeline. Then we have to upload our model. Then we have to create load our class names, and we have to create the initialize the webcam. Then read the frame and fill the vertically. We have to flip the frame and mention the landmark of our hand and the class name. We have to initiate here and the process inside the gesture detection and drawing the landmarks on our frame and predict the gesture and enter assigning the name of the gesture. Then we have to create the text of the gesture name. Then the final output has to be shown here. Cap.release, destroy all windows. So now again I run this, so you can see. Oh sorry, just a minute. I'm not connecting the camera. So again I run this. Now you can see. It takes some time to execute. Yeah, the frame is here. Yeah. Now we can see here I have to show my hand. So like this. So it is a live long. So already we have this seen in 10 classes, right? So it is a live long and now it is stop. So mostly it is related to the live long and stop. Now it is stop. You can see that name stop. Yeah, now it's stop and it's a thumbs up and thumbs down and it is a fist, I think fist. Yeah, it is a fist, it's a call me, and it's a piece. Then what is that? Yeah, rock, it's rock, okay, and a smile. Then which one is there? I missed something, anything. So at that time I can't do the one, so any one hand I have to show, so left or right, whatever. Now you can see only one hand has to be deduct, because already I have told, right, some issues we can't show the two different hands. At the time we have to show the only one hand. Okay. Why? Because I said like that means we have to train more with the too much images is needed for this class. Once we have to improve the class, that also we need a training. So still it is a 10 class names only we have to train. Okay, it's take too much time to training, that's why I said now I will try everything. So call me and fist, okay, it's a fist, and peace, smile, thumbs up, thumbs down, then yeah, thumbs down, yeah, rock, live long, stop. So which one we have to see the file. Almost everything was done, right? Okay, peace, thumbs up, thumbs down, call me, stop, rock, everything was done, right? Yeah. Okay. Fine. So now I enter in the Q button, it is execute. I mean close the window. It was close that window. So now we can see this place. So seconds wise, what kind of thing we have to do? So it's meter range wise, they have to showing everything. So this is the hand gesture deduction. I hope everyone can understand. So today you was discuss about the yeah. Today you have discuss about the what is image processing, like that things, and our today's major topic, techniques and algorithms, what all the things we have to discuss. Followed by this, remaining is there, the activation function, types of activation function, everything is remaining is there. Today we can continue with that tomorrow. Okay, so today we don't have to entering the same theoretical part because same things are happening, right? So it's getting bored, so that's why it's no needed now. Yeah, as well as I have to show the another things, just like I will show tomorrow. I will explain this. Okay, just I will show this one. The GAN model, already I said, right? Generative GAN model. They have to relate it to the image. Just a minute. Yeah, it's almost is there. It was MNIST digit generation. Okay, if I generate a concept, already I told the GAN model is having two kind of key factors. One is a this generated model, another one is a discriminated model, right? So now just like that, what is that exactly it's happening, I will show you. Practically do it. Will you provide us the trained data set? Yeah, of course we will. Today we will share that everything, the presentation and the code, everything we will share. So the data set also combined with that you can get. So now the class index having the 0 to 9. So randomly the numbers are shown into the image wise. So like this. Here just a sample image randomly it's getting. So every time I run this, the random image number will be there. So tomorrow we will discuss about this GAN model. Why I have to choose this means because it's containing the image thing, how the image generated here. That's we have to know, so that's why I have to choose this. Okay, I think internet is there. Okay, I already some cells will be run, so that's why, yeah. Here the epoch training will be there. So like this way we have to train our model. So epochs count wise we have to train our model one by one. Once it is done, the final output will be showing in a one tensor board wise, on UI wise they have to create. Okay, when it is what was that? Finish to the out of 10. Okay, still we have to wait. So now itself I only provided to the 10 epochs only. So we have to increase the epoch count, we can getting the better output. So why I said like this, you can wait and see this particular tensor board. Okay. So now only 2 it's remaining. So once it is done, we have to wait, see the another thing. Still 1 net is remaining. Yeah. So after the epoch done, so you can see the loss discriminator, loss generated. So we need discriminator only is getting this minimum of loss values. So why I can say like that means tomorrow I will say what is the loss value. Still we cannot discuss about the loss value, right? Tomorrow we will discuss the loss function and activation function, everything. So now the MNAST, the tensor board is there. So inside the board the image is there, right? So totally 8 steps. Okay, we have to reduce in the step. Fully is containing these too much noise. So once I increasing the one by one step, each step they have to getting clear image. So finally it is a 9 and one similar numbers only they have to show. Others is not clearly visible. So you can see the real image also it's not showing properly. So we have to increasing our epoch count. So we can only represent the 10 epochs. That's why our real image is not showing properly, not visibling properly. Okay, so it's a generated things. So based on the numbers wise, the digits will represent in a image wise. So tomorrow I will give an explanation about the GAN model and continue with this particular project. You can get one clearance. Okay. So every session I have to say tomorrow's topic, right? Tomorrow we can continue with that our official topic of advanced techniques. So image related concept we have done. After that we are comes into this kind of GAN model. Okay. So that's it. We can go with our regular process, like your time. We can go with that your time. So ready? Yeah. So try to find out the logo name. So this every logos it is a Python related one. Pythons and the machine learning's important libraries. So try to find out the names of the logos. I give a clue like this five libraries is important for Python libraries as well as machine learning libraries. Why everyone can stay calm? No one can no answer this. I given clue like that's everything. It is a Python library and machine learning's basic library. Yeah, Ape Jammu. Second one is a NumPy. Yeah, right. So you got 1 minute, so you can say everything. Yeah, first one is a pandas. Yeah, right. Lakshmita. Shivarao Shishadri. Yeah, first one is a pandas. Second is a NumPy. Third is a scikit-learn. Yeah, super nice. So what about the last two? Fifth one is a matplotlib. Yeah, nice. Arti, you give an answer, but you can change the position. First one is a pandas, last one is a seaborn. Otherwise, everything is right. First one is a pandas, is a pre-passing library. Second one is a NumPy, it helps to numerical Python, I mean handling the numbers. Third one is a scikit-learn, that was machine learning algorithms contains the machine learning algorithms. Fourth one is a matplotlib, it is a visualization tool. Seaborn, it is also another visualization tool in Python. Yeah, Seaborn, exactly, Lakshmita. Yeah. Yeah, Inita, yeah, right. Second one is a NumPy, yeah, right. How do everyone say find out the name NumPy? The N, then a letter is in N wise, you can find out the name. Everyone can start English said about the NumPy. Okay, fine, fine. So thank you. So tomorrow also we can try to meet with the different logos. Okay. So I hope everyone can understand this today's session. So if you have any doubts means you can immediately ask. Don't hesitate. So feel free to ask. You can't understand anything means you can immediately say to me. I will repeat it again. That was not an issue. Yeah, Naveen Rati. Yeah. Yeah, right. Pandas, NumPy, Matplot, yeah, right. Super. Puvarasi Krishnan, NumPy and Matplot. Okay, nice. Sheshadri, last one is the Cbon. Yeah, super. Nice. Okay, so that's it. Thank you so much. Yeah, thank you, KM Tohidul Alman Khan. Sir, thank you, sir. Yeah, okay, so ma'am, definitely we will try to share everything. The three presentations and what was that? The source code and everything. I think last 2 days I was shared everything. So still it is only it's available the YOLO object only, right? So today we will try to share this also. YOLO object and hand gesture. The both we will share it today. Which problem, sir? Opaque Jama. What kind of problem you have to face? The most common problem everyone can face the library import. So you can getting any module error, no module name open CV or CV2 like that way any getting. You can installing your library. So open the command prompt like this. I will show you. So open your command prompt and installing like a pip install. Open CV Python. It's a syntax for installing the Python library. Okay, sorry, now its version is there. You have to need a Python version. First, you have to Python installing the Python software. Then you can followed by the installation process. Still, my location is different. You can see I'm not following this location. That's why. Like I try to display the image like original scale, grayscale. Just we successfully displayed. Once run it pop up again and again, even if I don't run it. Okay, your question is you have to run at that time. You have to see the every images, right? Just a minute, I will open that one. Sorry. Oh, sorry, not here. If you run this means, so now you can like this. Yeah, it's a original image. Once you close this, you can get the blue image. Oh, now it's a blue. Okay, blue image and it's a green image. So like that, every image you have to close. You can get it the another image. Like this way, you have to get. You can try to ask this or which one, sir? Okay, again you try to run, it does not run the program. You can't run the program, right? Okay, sir, once I check why it is not do, you can't do that. Once I check and tomorrow I will give an answer. Okay, thank you so much, thank you everyone, thank you faculties. So if you have any doubt, you can post your doubt in a comment like group. our next upcoming session we have to try to ask like page jama sir. Yeah, okay, thank you. So thank you all, thank you. We will meet with the next session and see you